What's up, y'all? My name is Ryan Shewell. Welcome to my channel. So, in the topic today, I want to discuss global supply chain and create a risk tracker for this. Okay, now I'm going to make a couple assumptions, and basically, I'm going to read news from a news source, and I'm going to assume that most of the news is negative because most of the news that you see is negative. Okay, you almost never see news like, oh, this beautiful young puppy was adopted by a family, and these kittens were, just adopted into this very loving family. That's not the news, right? Like the news is pain, destruction. If it bleeds, it leads, right? That's what it is. So not all news is negative, and I understand that, but most of it is. Otherwise, it doesn't make it to the news, right? Like every news broadcaster knows that, and I think as human beings, fundamentally, we know that news generally is bad news. So you can say there's some good news, but again, the source of news is usually bad. And there's different ways to do this risk tracker. This is just one way. I'm not saying this is 100% guaranteed the way that you have to do it, but I think it's a very good general guideline. So why do we even do this type of analysis? To understand how resilient or how fragile a supply chain network is, okay? And supply chain resiliency is very paramount. It's very important across all different industries, right? If you have to ship something, some raw materials or some finished good, some final product from point A to point B, that is supply chain, right? And you want to make sure that it can get to its destination. We saw this in the news during the pandemic, which is a whole nother thing, the whole COVID thing. I think you know my opinion on that. That's like, it was really nothing really as far as I'm concerned. But like you saw a lot of things in the news about supply chain disruption, right? And it was all negative stuff, right? So that's the point, guys. News is negative, right? If it leads, it bleeds. Or if it bleeds, it leads. Sorry, I said that backwards. But anyways, like the goal here is to understand supply chain resiliency or fragility. We try to aggregate risk signals from various data sources. We want our data sources to be legitimate, even if it's bad news. Bad news is still bad news. We don't want fake news, right? I did a whole video on fake news and how to determine what's fake and what's not fake. So we're going to assume that most of the news is legit in this case. And it comes from Google. I think they have their own filters. I've never worked at Google or gotten anywhere close to working there. I would love to do that, but those opportunities never presented themselves to me, and that's totally fine. I'm going to assume that Google is filtering out all the illegitimate stuff and all the things like aliens are, coming to, invade Earth and take over all this stuff. I'm assuming that that's not there, right? So it comes from. We do have multiple news sources too, like RSS feed from Bloomberg, Reuters, Google API, things like this. So I'm going to use Google. In this case, you can see the URL right here. Okay, so that is going to be our Google source, and we're going to fetch a bunch of news articles. All right, so let me just kick it off. Control Enter to run the cell. Okay, and we have our news right there. So pretty fast, takes a couple of seconds. We have about 64 articles, not huge, right? But it's enough to get started and to do an analysis on. So you can see the source right here. It comes from Google, RSS search. And again, there's others, Bloomberg, Reuters, they're all fine. They're all totally fine. I'm looking at some keywords, right, for these news articles. So port delay, Suez Canal, tariff hike, labor strike, freight blockage, energy, gas, automotive, semiconductor, things like this. Things that you would generally see in some type of supply chain disruption or supply chain interference or something like this, right? So I'm just giving this a bunch of keywords and just doing the search, right? And getting the results back. That's the fetch for the data. So you can change this to be whatever you want, right? Like I'm going to give you all the source code. You can play around with it and fiddle around. Change search terms to be whatever you want. It's totally fungible and totally interchangeable. So this current approach really assumes that every article contains a keyword like labor strike or semiconductor. Otherwise, it doesn't come back, right? Like you have to search for something. If there's no search results, then you get nothing back. Some news might be neutral. A little bit might be positive, but mostly, again, I'm assuming is negative. If you find something positive here, good for you. The middle corridor, Renaissance and global retailers are struggling, shipping delays, labor strikes, Suez Canal blocking ports, union suspends, Russia-Ukraine war has impacted, right? It's all bad news, guys. So I think we can agree to agree on that. So now within those search terms, I'm going to create a list of keywords. And if those keywords exist in the search terms, then we're going to go ahead and um, pull back all of these news articles and concatenate everything right here. So PD concatenate is coming from the pandas library, or concatenate all of these new feeds, news DF, this is data frame. So if you search over here, we're creating a list that is indicated by the square brackets here. We're penning everything to a list and then concatenating everything into a nicely shaped data frame. So we have structured data to work with, okay? So if I go down here, yeah, okay. So we have 183 rows and 4 columns. The columns consist of title, published date, source, and then we have the link over here. So I think that's pretty apparent what's going on there. So we don't have a target variable here. So we're going to try to make predictions. We don't have a target variable. So if you've seen a lot of my other videos, you always have an independent variable and a dependent variable. The independents are the X variables. So anything that you're using to measure the target variable is independent, and the dependent is the Y variable. So you'll have a bunch of X variables, and it can be anything you want. You're trying to predict or measure some type of target variable. We don't have that target variable, so we have to create it. So we're looking for certain keywords inside of the text. So if port is inside freight or Suez, return shipping. Okay, so we're trying to create some type of target variable here based on shipping. If there's a chip or a semiconductor, that is going to be put into the bucket of semiconductor. If there's car or automotive or vehicle, that's going to be put into the bucket called automotive. So you can see we're trying to take just general terms and trying to create a few base scenarios out of these general terms. If grocery or food goes into the food bucket, if oil or energy or gas goes into the energy bucket, if tariff or tariff hike goes into the tariff bucket, and everything else is other. So these are the labels that we're trying to predict. Again, these are the Y variables. This is what we're trying to measure and predict. And everything else comes from the X variable. Okay, so the X is independent and the Y is dependent. So when I run that, Control Enter to run, we have our labels here. Just takes a second. Industry labels. This is shipping. This is coming from Suez Canal. Other, so it doesn't go into any bucket. Other, shipping, other, shipping, and tariff. Okay, so we have tariff over here. Ports, strikes, shipments, and tariff hike. That could actually be like a, why did that go into shipping? Let's see, port or freight. Oh, port, okay. So that could go into either bucket, I guess, because we have tariff and port in the same label. I don't think it makes any difference whatsoever in this case. If you did want to split that or maybe double count that title 2 times, that could be another outcome here. I don't think it really makes any difference, so I'm just going to leave it as it is. So, okay, moving down here to the next cell. If I go down, so we have the industry label, so we have the target variable, and we have the independent variables. Now we have to assign region labels. Okay, so we're trying to do a couple different things, trying to bucket these or bin these into certain categories. That's why we get shipping, other, tariff, things like that, right? So generally, we have to know the topic that we're dealing with, but we also want to know the region too, okay? So we're going to create 2 types of labels, an industry label. So we know, is this a semiconductor? Is this energy, automotive, shipping, whatever. If the we can also create a region label, right? So if the word is China, Asia, Taiwan, Japan, or India, this can go into an Asia bucket, right? Or an Asia bin. If you have Europe, Germany, UK, France, Eurozone, this could be Europe, and so on and so forth. We have United States or North America, right? Africa, and South America, and then unknown. So we have different regions around the world and different industries within those regions, okay? So hit Control Enter to run this. So you can see we have the original industry label and then the region label. So we have risk classification engine, industry and region, text classifications, BERT or scikit-learn, classify news articles by industry and by region. That's what we just accomplished. And named entity recognition, abbreviated NER, by extracting countries, cities, and company names from the text. So you can see how we're taking this text and parsing it up into different categories and different buckets and different bins. And then we're going to go ahead and make predictions on that. So we get down to the point where we're doing the machine learning part of the task here. So we have TF-IDF vectorizer and log regression. That's a classifier that we're going to use. It's actually a classification engine, not a regression engine. We have the X variable right here, and the Y variable is industry label. So here's the independent, here's the dependent. Based on the title, we're trying to predict the label, okay? So we have the TF-IDF vectorizer, we have the transformer down here, and we transform everything X test that comes in here, right? We split this into training and testing for the Y variable, right? So the X is always the independent, the Y is the dependent, and we have to split this. We're doing a split of 80%, so 80% for testing. I'm sorry, in this case, testing size is 0.02. Yeah, that's fine. That's fine. Okay. I just lost my train of thought for a second. The training is 0.8. The test is 0.02. The way to think about this is if you are in school, college, middle school, it doesn't matter. You're reading your books, you're going to your lecture, you're doing your homework, things like that. That is the training, right? When you go to take the test, you'll have at least a midterm and a final and maybe a couple intermediate tests in between. That is your testing phase. So 80% of the time, maybe 75% to 80% of the time, you are training. 25 to 20% of the time you are testing. Okay, so the machine learns kind of like a human. So we run this, control enter to refresh the cell. And the last populated has only one member, too few. Oh, I see what happens. Okay, we got too few in here. Oh, yeah. So that came back with different news articles. Let me see. Is there a way to fix this pretty easy? Let me see. We don't have enough variables here to create all these different buckets that we need. So we might have to use a little bit of logic to go ahead and get a minimum number of groups. Because if we don't have that minimum, then we can't do the training and the testing and everything else, right? So yeah, so we need at least two. If you can't do two, then you can't even split. So let me see here. Train test split. That. Oh, okay. So let me just change it just a bit. Let me get rid of the X and Y as is. Oh, that's fine. That's fine. Okay. So back here. Okay. Yeah. So if it isn't at least two, there's really nothing to split. You can't split it one, right? You need at least two records of something to be able to go ahead and be able to do the analysis. And look, we only have like several dozen instances of news articles over here, right? If you had hundreds of thousands, we wouldn't run into this problem. But sometimes, you get just a few records that you're working with. We can still do it. We just have to handle the logic correctly. Okay, so I think that is done. Let me hit Control Enter here. So at this point, we're getting the news data frame, published date, news data frame, published date, and then news data frame week. So we get the week and the data frame, right? So we have week, industry label, region label, and then risk count. And again, like I said, like maybe 10 minutes ago or whatever, we're not doing every single, yeah, it's fine, that's fine. Okay. Let me actually let me get rid of this too. Kind of doing this on the fly here. Control Enter. That's fine. Okay. And again, this is not like the absolute gospel truth of the way it has to be done. This is just one solution I came up with. I think it makes a lot of sense. But we do have to pull the data from somewhere. We do have to do the supply chain checking and tracking and things like this and measure the risk. So again, I'm using news and counts of news articles and trying to determine how how disruptive this news is, or how disruptive this topic is, and does it make it to the news, and then how do we measure and quantify that type of thing. So it doesn't have to be done this way, but I think this does make a lot of sense, and I think it illustrates the point pretty nicely. So we're classifying risks by industry and region. We already have the industry, we have the region, and then we have the risk counter. Okay, that's what this does over here. So anything that has, we're grouping by week, industry label, and region label, and then counting these, right? Looking at the size of the items in the data frame. Then we can move down here, and we have the train test split again, okay, based on news data frame, and the Y variable now is industry label and region label. So control enter to run it. So again, we're taking the vectorized returns of all these strings. Okay, we're taking all the strings, other shipping in Africa, Asia, unknown, and vectorizing these, basically converting the string to a numeric representation of the string. And once that is done, we can set the target variable right here to industry label or region label. Once that is done, we have the train test split with the X vectorized. If I do Control F, you can see that comes from over here. Again, we're taking the title of the news article, vectorizing that, right? Converting that to numbers. The Y comes from over here, right? Control F. We can search for the Y. We have the Y train and test. It's split into these two different categories like I described before. 80% is training, 10% or 20% is testing. The X gets the same sort of refined treatment there. And we got one class member, which is too few. Again, we got that problem. So we can probably do the same thing that we did before. We're measuring not enough news articles here. So it can't split something that just has one, right? It can't split one news article into two things. We have to have at least two. So let me see. If I go back to here, let me save this. Let me save this and refresh this thing. Okay. Okay, so here comes the refresh. Okay, so now we're down here. We have to handle this one single discrepancy here. Okay, so just look for this right here, valid industries, industry counts, right? Okay, control enter, we need at least one, get there, right? It still says it's one. Okay, so let me see. Okay, so we have vectorizer over here. Yeah, let me try to get rid of this. Okay, we're learning on the fly, guys. So let me see if this is going to work. Okay, so we got it. So again, we just have to make sure there's at least two labels for each of these dependent variables and the independent variables that we're looking at. If there is not, then there's nothing to split, and we can't even do it, right? Like you can't split a 1, a 2, you can split, a 3, you can split, and anything greater than 2, you can split. 1 is just 1. There's nothing to split into different buckets or different categories. So the ML algo just doesn't handle it because it just doesn't know what to do with it. So, okay, so we have the vectorizer, we're fine there. We have the dependent variable, we're fine there. Reinforced classifier, multi-output classifier, so we're fine there. This is multimodal. So this is kind of unique. Usually you have one target variable, okay? This is multimodal, so you have two target variables in this case. So we're trying to predict industry label and region label, okay? And you can totally do that. Most cases you have one target variable, but in this case I'm going to use two just because It's because we can, I guess. We could do this 2 separate times, but in this case, we can actually roll it into one single job, and we can just do it one time. So we need the multimodal um, output classifier. Again, this is kind of a rare case, but it's very interesting too. So we're making the predictions down here. So we have other shipping tariff, and we can see the results over here. Some of these classes are so small, we don't have tons and tons of news articles, right? Like ideally, you'd probably want to get thousands, maybe 10,000, maybe 20,000, and then do your training, testing, and evaluation. We don't have that many news articles over here. If I look, how many is it actually? Like we go up to 64. So in the machine learning world, or 65, right? Because you start with 0. In the ML world, that's just not a lot, guys. Like 64 records is just not a ton of stuff. So this algorithm is going to slice through it like it's nothing, right? If you had 64,000, that would be actually better for the analysis and better for the algo too. We don't have that many news articles. And if I did grab that many, I think Google would, put the brakes on that, and they wouldn't even allow it because I don't think they want you screen scraping 64,000 news articles. So in the interest of just making this thing work, I'm starting with a smaller data set just to get some kind of output and to make it work, and not to, make the people that work at Google frustrated, and not to get them to slam the brakes on this project. So, so we create the risk model, okay? So again, we're counting the risk, and I'm not saying that this is absolutely the only way you can do this. This is one approach. There's probably different ways to skin this cat. There's probably a whole bunch of different ways to approach this problem. But I think this totally makes sense, and it does illustrate the point pretty nicely. So I'm getting the max risk account. I'm taking the total risk accounts divided by the max risk account. This is the risk right here, risk count for all the risks in this category. Okay, if we go back here, it comes from over here, right? And we're doing the group by. Remember, we did the group by week, industry label, and region label. So if it falls into the same industry, same region, and same week, then there's a lot more risk there. There's a lot more risk in that, concentrated in that one area. Like right here, we have 2. Okay, so in that 1 week, there's shipping, industry, and region unknown. Oh wait, I'm sorry, above that, right? Shipping and unknown, and it's 2 articles in this week. So we're taking the density or the counts of frequencies of the industry, the region, and the week that it falls into. So you can see a lot of these are pretty low. There's not that much risk. The risk is pretty much diversified and spread around a bunch of different industries and a bunch of different regions around the world. But if by chance you see a whole bunch of shipping and the region was North America or Asia or something like that, then that would be much more of a concern, right? So here the risk is pretty low. This is 1% risk. These are all like 1%. This is 3%. But if you see this spike up, that's where you want to pay attention and say, okay, well, we could have a potential global supply chain issue over here. There was one in the Suez Canal when that ship was jammed up 2 or 3 years ago, maybe. Suez. Let me see this thing. I'm sure you have heard about Suez Canal crisis. There it is. So it comes up number 2. This was. Oh wait, was this even? No. It's totally different. Supply chain crisis, right? That was it. Oh yeah. So 2024. So just over a year ago, about a year and a half ago, there's that ship Ever Given. What was it called? Ever Given, and the thing jammed up the whole Suez Canal, right? So if you see something like that, right, and there's a lot of news coming from the Suez Canal and coming from, this region of the world. What is this? Middle East, kind of close to Asia. That's not really Asia per se, but if you had a bunch of risk around that, that is something that you need to be aware of, and that's something you need to manage very quickly and very carefully. Okay, so that's what we're doing. We're trying to look at the overall risk, assign scores based on industries and regions. So normally the raw risk count is going to be pretty low. I think if it jumps up, if you see a spike, then action needs to be taken, right? You have to set up team calls or meetings with your team, get on the phone. This is go time, guys. This is crisis mode, and you have to figure out what you're going to do, right, to backpedal and get away from that area, right, and reroute your ships to another port or whatever, or like plan or something needs to be done, right? Like you have to take action. So so that is what the data frame looks like. We have the regions labels. week predicted industry, predicted region, so on and so forth. Let me refresh this cell and then move down to the next one. Okay. And again, we're assigning risk scores. It's the total number of risk articles divided by the maximum. So this actually is kind of high right here. So we have 35% risk score. This is 100%. This is shipping and unknown. I think because this category, this predicted region, isn't as defined as it could be, right? So that could be a real issue, shipping and unknown. We have number of articles 34 and 100% risk score. So that's something that needs to be dug into and needs some attention, right? This could be just a case of maybe the predicted region is not not nuanced enough or not as well defined as it could be because we're getting a lot of things thrown into the unknown bucket. Um, but maybe that's fine too. I mean, that's more of a judgment call. I can't say for sure. Is this an issue? Is this a non-issue? I can't say. But the risk score at 100%, that definitely needs some attention. And either define that predicted region better, right? Or take action on that, right? Because shipping and unknown is getting a pretty high risk score over here. So what can we actually do with this, right? So we can create a couple of heat maps, and this will draw our attention to this issue that I just described, right? Like here's 100% region unknown. We have 1.0. This is a risk score. Okay, this is the one that we just saw, 34 count, right? So that is unknown and shipping. So these two intersect. The shipping is on the y-axis over here, and the x-axis has unknown. So 100% risk, that's what we're looking at over there. This has 35% risk. This is shipping North America. So if we're shipping North America, this has 35% risk. So if you zoom in on that, you can see that guy right there. So overall, this heat map will show you pretty clearly there is a big issue with shipping and unknown. When we look back here at this, we can see that kind of clearly too. But this heat map really draws out for you, right? It really pops off the page here, off the monitor, and you can see this is a big issue. Again, I think we just have to define these regions better, and this could be a non-issue. But if this is a serious issue, it needs to be addressed. Okay, so again. Any industries that need to be reformed or reshaped, that has to be addressed, and any regions that need to be drilled down into or defined better, maybe that needs to be addressed, or this is a real issue. Okay, so it could go a couple different ways. So let's look at just a couple more examples here. We're doing news group by week, predicted industry, and predicted region. Again, doing all the counts over here. So here's the number of articles based on predicted industry, predicted region, and then we're doing the counts over here. So nothing really jumps out at me. Kind of this one spikes up a little bit, 4. It's only a 4. We have a couple 3s down here. So kind of not really big issues. 3, that's not really a big issue, but maybe something that we need to be aware of nevertheless. Okay, so let me refresh this. You can see the timeline of news articles over here. So we have other shipping tariff. So we have a big spike over here. And the counts jump up to, well, it doesn't jump that high. That's the 4 that we just saw. We saw a couple of 3s over here. This is a 2. This is a 1. So this just shows you a timeline of these news articles as they occur over time. So a little bit different from the image that we get from here. This is more of a heat map kind of solution, and this is more of a temporal time series graph over here, okay? So anything that has a risk score greater than 2, I'm going to focus on that just because these risk counts, did that change or something? Risk count. And then we have the chart here. And I'm kind of like blown away by all these things I do all the time. The code works one day and then you come back and then the code doesn't work at all. So I'm not sure why this is so random, because I've been doing this for years and years and years. I've never seen this kind of randomness until recently. Oh, so something changed. Score. Articles. Let me just see if that was another data frame that got deleted or something. Risk counts, risk count, risk score. So that is that. right? So maybe I just didn't refresh the cell or something like that. I guess, yeah, I guess I skipped one cell. Okay, so whatever. The computer does what you tell it to do 99% of the time, but sometimes it has its mind of its own. So anything here, I'm highlighting anything that's greater than 20%, okay, 0.2. And I'm looking at just these risk scores over here. So you can see this 0.33, 0.10. Actually, I did say 0.10. Greater than, I could do greater than 5, right? So these would be the top risks. So 0.67, just because it has a high count. Again, shipping and unknown. But a lot of these go back to that unknown. Like these region labels probably could be defined a little bit better, or just better definition, more definitive, whatever you want to call it there. So this might be more of an issue. This is shipping in North America. There could be news articles out there about shipping in North America causing some supply chain disruption. This is shipping unknown. Probably we need to just give some more context or character around that. And that is going to clear up that issue right here. And then we can jump down here. We have just a couple more examples here of how to analyze this risk and assess it and manage it. So we have positive, negative, and neutral. So we're getting away a little bit from just the overall risk and assigning more of a kind of a characteristic where we're looking at, is something positive, is this something negative, or is this neutral? Because again, like I said at the beginning, I said it a couple of times, I'm assuming all this news is kind of negative news, but some of the news could be positive and it could be neutral, okay? That is somewhat unusual, but that could happen, right? So to do more of a fine-grained analysis, I would say, we don't have to just assume that all of the news is negative and that some of that actually could be positive. That could happen. That's a little bit rare, but it could be positive or neutral. But most of the time, I think it will be negative. So we assign -1 to negative. Neutral is going to have 0, and positive is going to have 1. And we're looking at the net risk overall. So the sentiment map, again, 1, 0, -1. News sentiment is mapping this news sentiment that we just captured right here. We just created and captured right there. And we're looking by news data frame and then group by week, predicted industry, predicted region, and then sentiment score. So here's the final data frame and the head and the tail of this. Okay, so if I hit Control Enter, I think I just refreshed it. I'll just do it again to make sure, because there's one I didn't capture before, and it was telling me the data frame and the the column didn't exist, but it did exist. It just wasn't refreshed. So we have the week, the predicted industry, predicted region, the net risk based again on the sentiment. So positive, neutral, negative. So we're looking at more than just all negative news, assuming everything is negative. We're actually assigning a sentiment, like a feeling, that's a feeling that you might have, to positive, neutral, or negative. And then again, we have this heat map to wrap it up. So in the end, we have the weekly sentiment risk that comes from the previous data frame that we just created over here, grouping by week, industry, predicted region, and then sentiment score. And that's what we're summing up. And then we have our final heat map. So you can see anything that is light has a negative sentiment over here. So shipping and unknown. So this has more of a negative connotation, right? So we see the -1, it's going to be negative, right? Anything that's neutral is going to be 0. So that's going to be kind of in between, kind of like tannish, a little bit gray, something like that. And anything that has a 0 is going to be more positive, right? Or more optimistic. So this has a 0. So this could be a combination of a little negative, neutral, and a little positive. This is, or all neutral, right? To get 0. So we could have an average. We could have just all zeros. This is a little bit negative over here. Asia shipping a little bit negative. North America shipping kind of negative, -12, and then unknown shipping -20. So it's highly negative. So that is more of a risk concern, right? And this is something that needs to be checked up on with the team again. So set up a meeting, invite the key stakeholders to the meeting, and figure out what needs to be done here, right? Is this a real issue? Maybe it's a non-issue. Again, maybe this definition has to be improved. Maybe unknown isn't descriptive enough, right? Everything gets thrown into this bucket and we don't really know what that is. But also, if you think about it, that's kind of an issue too. Like if we have a lot of negatives and these are unknown and we can't define what that is, Is that really how you want to be running your business? You want to conduct business with a lot of unknowns that are negative? Probably not, right? So it probably has to be looked into. And again, at least it fleshes out some interesting topics for discussion, right? And it gives you a chance to engage with your team and to try to dig in and try to figure out what the heck is going on here, right? If we have a lot of shipping unknown negatives, that can be a real issue. Maybe it's not so much of an issue, but you have to have that meeting, you have to have that discussion and make that determination. Okay. So I'm going to wrap it up here, guys. What did we achieve today? Basically, global supply chain risk tracker, kind of simplistic. You can take this in a couple of different directions. I acknowledge it. I understand that. But I think this is a good starting point. I think it's an excellent starting point for some discussions and to understand from the news and from the point of sentiment analysis, again, positive, neutral, and negative, what's going on with your supply chain business. That's what you have to understand and be able to answer those questions, right? So this removes bias. Not all news is bad, but most of it is, right? Improves accuracy, improves decision making. You can make more informed, more intelligent decisions using this type of construct, right? This type of methodology. It supports trend detection, right? We're looking at temporal news articles that are coming out constantly, right? And these things change over time. And we created a few heat maps, right, to help draw attention to the issues that are most salient and most pressing, and they deserve the most attention. Okay, so I'm going to wrap it up here. Thanks for your time. I will share all the code with you guys like I do with all these videos. I'll post the code. I'll post a video later today. You'll have everything you need. If you have any comments that could be helpful, please put that in the comment section. If you want to see similar videos to this, maybe slightly different topic, different take on it, go in a different direction, let me know about that. And I think that's it. I'm going to wrap it up here, guys. Thank you so much for your time, and I'm going to drop another video later today. I'll see you soon. Bye.